So, hello everyone. So, this is the report of Group 7 Traffic Engineering entitled Traffic Studies. So, this is our agenda for traffic studies. We have five components. The first is traffic characteristics, traffic studies. So, under this is the speed, volume, speed, and delay. The third one is traffic studies. Under this is origin destination, parking, and accident studies. The fourth one is capacity of urban roads and highways, traffic operation and control. And lastly, design of intersection at grade and grade separated. So what is traffic engineering? So traffic engineering is a branch of civil engineering that focuses on the design, analysis, and optimization of transportation system to ensure the safe and efficient movement of people and goods on roads, highways, streets, and the other transportation infrastructure. So, mag-focus ang traffic engineering mostly sa ato ang highway design. So, for example, sa US, so na sila ay bike lanes dito para ma-utilize ang ato ang highway or roads nato para ma-lessen ang traffic and to lessen the traffic volumes ato ang mga dalan. So, traffic engineers aim to balance the needs of various roads users including pedestrians, so na-involve na diri ang atong cyclists and motor vehicles to create transportation systems that are safe, efficient, and sustainable. So, traffic characteristics. So, ma-classify ang ato ang characteristics in two types. So, the first one is road user characteristics and vehicular characteristics. So, road user characteristics. So, physical characteristics such as vision, hearing, strength, and reaction to traffic situation. Mental characteristics such as knowledge, skill, intelligence, experience, and literacy. Psychological characteristics such as emotional factors such as fear, anger, and anxiety. And lastly, environmental factors, traffic stream conditions, atmospheric conditions, facilities to the traffic, locality, and etc. So vehicular characteristics, there are three components. Static characteristics, it involves dimensions of vehicles, length, width, and weight, wheelbase, departure, ramp angles, the front, rear, and the center clearances, and also the weight, maximum, and the turning angle. So dynamic characteristics such as speed, acceleration, power, and braking characteristics. And lastly, braking characteristics, vision, eyesight, hearing, strength, reaction time, and judgment power. So traffic studies. Traffic studies refer to a set of research and analysis conducted to assess various aspects of traffic flow, patterns, and safety on roadways and transportation system. So these studies are typically carried out by transportation engineers, urban planners, or government agencies to inform decision making related to road design, traffic management, and transportation infrastructure improvement. So ang atong engineer diri, highway engineers na to is sila gid mainly ang reason para ma-lessen or to avoid casualty and damages or accidents ato ang highways nato. So sila gid ang design sa ato ang highways para prevent ni. So ila na yung na calculated para malikayan sa isa tagsa-tagsa natong mga sakyanan ng mga traffic or malesen ang traffic. So traffic studies, there are seven under these studies. So the first one is traffic volume study. Second, speed studies. Third one is origin destination study. Fourth one is traffic flow characteristics. Fifth is traffic capacity study. Sixth is parking study. And lastly, accident studies. So in my part, I will be just discussing traffic volume study, and speed studies. So traffic volume study. So traffic volume is the number of vehicles crossing a section of road per unit time at any selected period. The unit for traffic count is generally taken as vehicles per day or vehicles per hour. So sa tuang mapa dire makita nato nga the color red indicates the volume of the traffic nato kung how frequent ang atuang lane dire nga mo-occur ang atong traffic, while ang atuang yellow dire is mild lang ang atuang traffic nga may tabo, while ang green nato is free ang atuang mga vehicles nga mudagan, or there are no traffic or any sort of hindrance nga present. So traffic volume study, there are two ways to be done. So first one is automatic counters and manual counts. So automatic counters are typically used to gather data for determination of vehicle hourly patterns, daily or seasonal variations, and growth trends or annual traffic estimates. So while the manual counts are typically used to gather data for determination of vehicle classification, turning movements, direction of travel, pedestrian movements, or vehicle occupancy. So, so selection of study method. So diri na to makita ang atoang study method kung giyon sa pag-determine sa atoang engineers ang atoang traffic. So makita diha, selection of study method is determined by using the count period. It could be day of month, and month of year for the study area. Typically counts periods are 15 minutes or 2 hours for peak periods. So manual count, dili nato makita, tally sheets, mechanical counting boards or electronic counting boards ang paggamit sa atua manually para makuha nato ang traffic. So diri ang atoang natay tally sheet diri atong presentation diri on how frequent a vehicle may go or pass on a certain area on the road. So for example, dire ang atoang car dire ka 20 siya dire ni pass mga cars dire on this side of the road, while on this side of the road we have 30 cars passing. Truck cars, we have 5 truck cars, and this one is just 2 cars passed, and cars trucks here 17. So these are just some examples on a tally sheet. So traffic volume study. So mechanical count boards consist of counters mounted on a board that record each direction of travel. Common counts includes pedestrian, bicycle vehicle classification, and traffic volume counts. So mo siya example sa ato ang mechanical counting board. Yan eh. Ay mo na mo count na to. Atong pedestrian diri mga atong bike. Nasa ang atong bike lanes na to. So electronic counting boards. So they are similar to mechanical counting boards but with some important differences. Electronic counting boards are lighter, more compact, and easier to handle. So mo ni siya examples ato ang electronic counting board. Yan siya. So traffic volume study. So automatic, ang atong automatic counting method. Automatic counts are usually taken in a 1-hour interval for each 24-hour period. The counts may extend for a week, month, or year. When the counts are recorded for each 24-hour time period, the peak flow period can be identified. So steps to an automatic count study. So an automatic count study includes 3 key steps: perform necessary office preparation, deploy and calibrate data collection equipment, check data and retrieve protect equipment, and lastly perform necessary office preparation during office presentation. So, mo ni siya ang to ang recorder. Example lang ni siya. Pneumatic road tube recorder and recorder. Itong dala na to. So, now let's talk about speed studies. So, speed studies are necessary because the actual speed of vehicles over a particular may vary depending on various factors such as geometric features, traffic conditions, time, place, environment, and driver. Speed studies can be studied under the following heads. So, the first one is travel time. Is the reciprocal of speed and is simple to measure of how well a road network is operating. Spot speed is the instantaneous speed of a vehicle at a specified section or location. Average speed is the average of the spot speed of all the passing vehicles at a given point on a highway. Running speed is the average speed maintained by a vehicle over a particular stretch of road while the vehicle is in first motion. And lastly, overall speed and travel speed is the effective speed with which a vehicle transfers a particular route between two terminals. So, mo siya? Spot speed study and speed and delay study. So, spot speed study, when we measure the traffic parameter over a short distance, we generally measure the spot speed. A spot speed is made by measuring the individual speed. So, spot speed study, when we measure the traffic parameter over a short distance, we generally measure the spot speed. A spot speed is made by measuring the individual speed of a simple of the vehicle passing a given spot on a street or highway. So these are the following, including the speed trends, traffic control planning, accidental analysis, geometric designs, and research studies. So muna siya yung mga factors na to sa to ang spot speed study. So spot speed study method of measurement. So spot speed study measure. So spot speed study method of measurement. So methods of conducting spot speed studies are divided into two main categories. The first one is manual and automatic. Spot speed may be estimated by manually measuring the time it takes a vehicle to travel between two defined points on a roadway and known distance apart, or the short distance, usually less than 90 meters. Distance between two points is generally depending upon the average speed of traffic stream. So, muna siya ay ato ang visual representation sa ato ang spot speed measurement method. So, from this part, we have our starting point to the finishing point. So, we have our data right here. So, from average speed of individual group from Panto Path to Russell Square. So group 1 we have 18.43 miles per hour, group 2 has 16.38 miles per hour, and group 3 has 19.48, and their overall average is 18.10 meters per hour. While the average speed of the individual from the Russell Square to Panto Path, so group 4 has 20.33 miles per hour, group 5 has 20 miles per hour, group 6 has 16.92 miles per hour, and their overall average is 19.008 miles per hour. Therefore, we conclude that Russell Square to Panto Path is has less traffic stream than to path to Russell Square. So speed and delay studies. So speed and delay studies give running speeds, overall speeds, fluctuations in speed and delay between two stations of a road space far apart. They also give the information such as amount, location, duration, frequency, and causes of delay in the traffic stream. Various methods to carry out speed and delay surveys are floating car method, license plate record method, by interview, and by photography and videography. So floating car or riding check method. So in the floating car method, a test vehicle is driven over a given course or of travel at approximately the average speed of a stream, thus trying to float with the traffic stream. A number of test runs are made along the study stretch and a group of observers record the various details. One observer is seated in the floating car with two stopwatches. One of the stopwatch is used to record the time at various control points like intersections, bridges, or any other fixed points in each trip. So the other stopwatch is used to find the duration of the individual delays. The time, location, and cost of these days are recorded by the second observer. So the number of vehicles overtaking the test vehicle and overtaken by the test vehicle are noted in each trip by the third observer. So the number one, so vehicles traveled in the opposite direction in each trip is noted by the fourth observer. So in the last, so in this method is the detailed information is obtained concerning all phases of speed and delay, including location, duration, and causes of delay. So right here we have our formula for our floating car or riding check method. So here is t is equals to t sub w minus n sub y over all over or over q, where t is the average journey time in minute, q is the flow of vehicle in one direction of the stream. So n sub y is the average number of vehicles overtaking the test of vehicles minus the number of vehicles overtaken when the test is in the direction of q, and t sub w is the average journey time in minute when the test vehicles is traveling with the stream q. So in the second formula we have q is equals to n sub a plus n sub. Oh, okay na to? Ay, okay na to. Ikat na to. So in the second formula we have q is equals to n sub a plus n sub y all over t sub a plus t sub w, where our n sub a is the average number of vehicles counted in the direction of the stream when the test vehicle travels in the opposite direction, while t sub a is the average journey time in the minute when the test vehicle is running against the stream q. So methods of speed and delay. So this will be my last part of the report. So study license plate method. So asynchronous stopwatches or voice recorded equipment are used. Observers are stationed at the entrance and exit of a test section where information of travel time is required. So interview technique. The work can become completed in a short time by interviewing and collecting details from the road user spot. However, the data collected may not provide with all the details correctly. And lastly is the elevated observation and photographic technique. These are useful for studying short test section like intersection. So that would be all for my report, and thank you.
Good day, everyone. So at this juncture, I will be discussing the origin and destination study. Traffic engineering plays a crucial role in designing efficient transportation systems, and one key aspect is the analysis of origin-destination pattern. So what is origin and destination study? Origin and destination study. This refers to the study of where trips start and where they end within a given transportation network. The information gathered from studying these patterns helps urban planners and engineers make informed decisions to enhance traffic flow and improve overall transportation infrastructure. Example, let's consider a simplified example of a city's transportation system. If a significant number of commuters travel from a residential area to a central business district during morning rush hours, understanding this origin destination pattern becomes essential. With this knowledge, city planners can implement targeted measures such as optimizing traffic signals, creating dedicated lanes, or improving public transportation options. The analysis of origin destination patterns often involves collecting data through surveys, sensors, or advanced technologies to identify travel patterns and peak times. By understanding where people are coming from and where they are going, traffic engineers can devise strategic solutions to enhance transportation efficiency and contribute to a more sustainable and commuter-friendly urban environment. So here are the information collected in this pattern. First is the place and time of origin. Second, place and time of destination, route, purpose of the trip, types of vehicles, and the number of passengers in each vehicle. So here is an example or standard format of origin destination survey. We have here the where did your trip begin, what type of place is your trip start point, and so on. So in conclusion, the origin destination analysis is a vital component of traffic engineering, providing valuable insights that guide the planning and implementation of measures to address specific travel patterns within a city or region. Now, let's proceed to parking and accident studies. What is parking studies? One of the problems created by road traffic is parking. Not only do vehicles require street space to move about, but also do they require space to park where the occupants can be loaded and unloaded. The period over which a car is parked is very great compared with the time it is in motion. Every car owner would wish to park the car as closely as possible to his destination so as to minimize his walking. Parking studies in traffic engineering focus on evaluating and optimizing parking facilities to address the demand for parking spaces. This involve analyzing factors such as the number of parking spaces, their locations, usage patterns, and the impact on traffic flow. For instance, a parking study may assess the adequacy of parking spaces in commercial area by considering factors like peak hours, average parking duration, and the types of vehicles typically parked. The goal is to ensure efficient parking management, reduce congestion, and enhance the overall accessibility of an area. So in parking studies, there are types of parking facility. First is the on-street parking. On-street parking is also known as curb parking, as in this type of parking, the vehicles are parked along the curb of road. On, on-street parking can be done in three ways. First is parallel parking, parallel to the curb. Angle parking at certain angle with curb. And lastly, 90-degree parking at right angle to the curb. Second is the off-street parking. In this type of parking, the vehicles are parked in specifically designed and prepared parking areas. They are in the form of parking lots, porches, shades. Parking lot is the open area either on the roadside or near the market or business center and etc. Now let's proceed to accident studies. Accident studies involve analyzing traffic collisions to identify contributing factors, assess safety risks, and develop strategies to reduce accidents. This includes examining locations with high accident rates, studying the types of accidents, and considering factors like road design, signage, and traffic regulations to enhance overall safety. So how to prevent accidents? First, we have engineering, design of roads, selection of safe design, speed, channelization, particularly at intersections, width of shoulders, parking, curbs, traffic control devices, minimize number of entries or exits, controlled pedestrian crossing. Next is education, like training drivers, understandable signboards, symbols, media, radio, TV advertisement, talk shows, or create public awareness. Next is distribution of pamphlets to drivers, school children's parents, lectures in schools, colleges. And lastly, enforcement. Enforcing traffic law, strictly check on drivers' vehicle condition. Patrolling of law enforcing persons. Annual check of vehicle condition before renewal of vehicle license. It is complete check-up including engine, lights, and etc. It is a must in developed countries. So that's all. The next reporter will discuss for further details. Thank you.
Good day, I am Dan Bray Sigario and I'm here to report about capacities of urban roads and highways. Existing traffic services levels for all road sections are determined using traffic data from the Road Traffic Information Application or the RTIA, the Road and Bridge Information Application or the RBIA. Future service levels for each road sections are identified using a transport model, e.g., assigning projected transport demand to the network or using simpler method of projection of traffic volumes by section at the regional level. The RBIA is also the repository for data related to the road geometric and operational characteristics such as the pavement type, carriageway width, number of lanes, and the roughness measured in units of internal roughness index or the IRI. This constitutes the basic road information required for running the HDM for applications. This information together with baseline traffic data and future traffic is required to establish the existing and future traffic service level for each road section to pinpoint so-called hotspot of traffic congestion measured as the hourly designed traffic volume over the road section or the basic hourly capacity in car units BHCC called the volume capacity ratio. So ang basis sa ato ang kuan sa atong capacity sa roads o sa highways kay mo ni siya ang volume capacity ratio. One of the important parameters in the VCR is the road capacity, which according to the Highway Capacity Manual or Highway Research Board of Washington, D.C. from 1965, mo ni siya ang kuan basis sa tanan nga or halos tanan nga highway capacity nga kuan kanang research. It is defined as follows. Now, capacity is the maximum number of vehicles which have a reasonable expectation of passing over a given section of a lane or a roadway in one direction or in both directions during 1 hour under prevailing road and traffic conditions. The traffic volume at the upper E level is per definition equal to the capacity.
So kaning capacity muni siya ang kaya nga i-hold or kaya nga mulabay sa usa ka road or highway under an hour. Muni siya ang ratio niya. So dapat naatay dapat naatay road capacity kay important man siya para sa para ma-measure nato ang change. Laban na if example if kaning area is nagkadaghan ba ang muagi or if if need ba ni siya i-widen ang road yan para sab sa pag-maintain sa atong dalan. So next, the VCR calculation system is illustrated below. Level A means free-flowing traffic. VCR is less than 0.20. So level B, relatively free-flowing traffic. VCR is between 0.21 and 0.50. Level C, moderate traffic or VCR is between 0.51 and 0.70. Level D, moderate heavy traffic. VCR between 0.71 and 0.85. Level E, heavy traffic or VCR between 0.86 and 1. Muna rin siya gatong mga dagko na kayo nga highways sa syudad nga di nahapit mo lihok. And level F, unfortunately, napay mas mas congested yun nga nga mga highway. Sabutan na di na gyud hapit mo lihok ang traffic. So saturation traffic volume stop and go situation. Next, at level F, the capacity will actually start to drop because of heavy congestion and low travel speed. The hourly capacity is influenced by the following factors: the number of lanes, carriageway or lane width, shoulder width, gradients, and their lengths, truck and bus percentage of total traffic, lateral obstructions on both or one side of the roadway, and roadside friction. So, kani mo na siya ang mga factors nganong dili hapit mo lihok ning sa level F. So, ang number of lanes, kung unsa pila ka lanes and unsa pud kadaka ni carriage width, mo gini sila yung mga main factor. Usahay pod gibisan pag unsaon yung pagpadako ang lane, nara gyud gyapon tendency nga mo traffic gyud gyapon siya. Kuni isa sa mga dapat pangitaan o solution sa mga engineers. Isa ni siya sa mga problems nga need og immediate nga solution. Next, the degree of roadside friction impact on road capacity is described as follows: none, few or no building along the roadside, light, buildings and or road intersections along and close to the road, 100 to 200 meters between these objects, pedestrians and non-motorized traffic, observed observed occasionally, medium, scattered roadside development, 50 to 100 meters between buildings and or road intersections, pedestrians and non-motorized traffic, observed frequently and heavy, continuous roadside development with less than 50 meters between buildings and or road intersection, pedestrians and non-motorized traffic tend to disrupt the motor vehicle traffic and reduce travel speed below between 35 kilometers per hour even at low traffic volume. Kani siya isa sa mga external factors na dili lang ang dalan man gud ang reason nganong mag-traffic. Usahay kay kanang mga building sa kilid-kilid or kung unsa ka scattered ang development sa atong building, may mga guba nga dalan, inana mo na siya mga reason sa next. Yung ako ng traffic operation, no? So that's all para sa akong report. Thank you for listening.
So the next topic is the traffic operations and control. So traffic control involves directing vehicular and pedestrian traffic around a construction zone, accident, or other road disruption, thus ensuring the safety of emergency response teams, construction workers, and general public. So sa traffic control, also includes the use of CCTV and other means of monitoring traffic by local or state roadways authorities to manage traffic flows and providing advice concerning traffic congestion. So, ang traffic control kay there are three major traffic control devices. These are the traffic signs, traffic signals, and roadway marking. So, sa traffic signal, kay kabalo naman ta, di ba? So, traffic signals are provided at road intersection. These are control devices which direct or stop the traffic using red and green signals. So, there are three types of traffic signals. These are traffic control signals, pedestrian signals, special traffic signal. So why traffic signal? Most roadway intersections are not signalized due to low traffic volumes and adequate sight distances. At some point, traffic volumes and cross frequency is very high, so we have to install traffic signals. So mao ni siya rason kung nganong naay traffic signals. Kay kaning ni siya kaning mugay bitaw sa traffic. Mugay. So, traffic signals, ang example niya is ang traffic light. So, kailan naman siguro tag traffic light, no? Basically, naani siya sa mga big cities, sa mga cities. So, kabalo naman to sa mga mga color. So, ang red, it means stop. Ang green, it means go. Ang yellow, it means stop. If you can do safely, the light will soon be red. So, stop na kahinay-hinay before siya mo red. Mag-stop na kahinay-hinay siya kay. Pag red kay, you must stop. You must stop magyud. I-stop magyud imong vehicle So, next is ang lane signals. So, ang lane signals are used when the direction of the flow of traffic changes to show that a toll booth is open or closed, to show which lanes are open or closed. So, ang lane signals o ang traffic signs, kay murag pari-pariha na sila. Kay naman ni siya, red na color, it means stop. Ang yellow, it means you must stop slowly because it goes to red. Ang green kay it means go. So next is the regulatory signs. Regulatory signs are used to inform the road users about laws, regulations, and prohibitions. There are 5 various regulatory signs. These are the stop, give way, speed limit, no parking, direction control. So these are the example of the regulatory signs. Stop, give way, one way, no entry, one way, no way both direction, right turn prohibited, left turn prohibited, U-turn prohibited, overtaking prohibited, o napay lain. Speed limit, horns prohibited, napay lain, dagan pa. So sa warning signs po, kay warning signs are used to warn the road users of certain hazardous conditions that exist on roadways. They have white background, red border, and black symbol. So ang example kay crossroad, gap median, side road right, side road left, Y intersection, T intersection, staggered intersection, major road ahead, roundabout, dangerous dip, hump or rough road, o napay lain, dagan pa na. So ang informatory signs, so next ka informatory signs. So these signs are used to inform the road user along route, destination, and distance. So nanapoy 7 ka various informatory signs. These are the route markers, route turn arrows, directional arrows, familiar destination, millage sign, recreation area service sign, location of airports, bus station, and train station. So example ana kay ang public telephone, petrol pump, hospital, first aid post, eating place, light refreshment, resting place. So ang most familiar lang ni kay ang hospital kay 'di ba pag naka sa cities tas emergency 'di ba pag kini na line padulong ni siya sa hospital. So makita nimo to siyang sign dito nga hospital. Then naapod siya ipaaraw na kung asa dapit padulong ang hospital. So next ay ang roadway markings. So there are 4 types. First is pavement marking, curb marking, object marking, and the last one is reflector unit marking. So pavement marking are generally of white. Yellow color marking are used to indicate parking restrictions and for continuous center line. While curb marking indicates regulations, alternate white and black line. Object marking also is a physical obstruction on or near roadways or hazardous, hence should be properly marked. So the last one is the reflector unit marking. Reflector markers are used as hazard markers and guide markers for driving during night. So ang example ana kay kining makita ninyo sa dalan na ay kining edge marking, lane marking, center marking. Mura siya ang solid yellow, solid white line, solid yellow line, solid yellow broken line, yellow broken line. So ang traffic operations and control in general kay mag-guide ni siya not only sa drivers but also sa passengers to stay safe sa road. Kay kabalo na ta pag pag driving na nag-cause og accident, dako na kay siya og damage sa properties, sa ato ang health. Kay di ba dili kasagaran man pud pag magpataka og drive kay man do kasagaraan na kay siya may tabo pero maglikay na lang gid ta magkuan sa mga traffic operations and control. So mao na to.
I'm Jazin Ramirez and I'm here to report about intersections design. So, intersection is an area shared by 2 or more roads. This area is designated for the vehicles to turn to different directions to reach their desired destinations. So, this is because vehicles moving in different direction want to occupy same space at the same time. There are 2 main types of intersection. So, una is grade and the second one is at. So, ang grade is to separate intersections or interchanges. At is grade intersections. So, the first type of intersection design is grade separated intersections or interchanges. So, bridge daw ni siya that eliminates crossing conflicts at intersections by vertical separation of roadways in space. So kasagaran na to ni siya makita sa mga Manila na kanang mga busy nga lugar. Wala man kay siya sa probinsya kay dili ra man kay siya traffic. So ang route is to transfer at grade separations is accommodated by interchange facilities consisting of ramps. So the ultimate objective of grade-separated intersection is to eliminate all grade crossing conflicts and to accommodate other. So gamit kayo ni siya para ma-lessen nato ang traffic and at the same time dili kayo crowded ang karsada. So, intersecting maneuvers by merging, diverging, and weaving at low relative speed. So, ang major interchanges sa grade-separated intersection or interchanges are underpass, overpass, trumpet interchange, diamond interchange, cloverleaf interchange, partial cloverleaf interchange, directional interchange, and bridge rotary. So, ang second main type sa intersection design is at grade intersection. So, ang grade intersection is kuanday siya, all the exchanges between roads takes place on the same plane. So, ang at grade intersection kay na two types. Ang standard at grade intersections o roundabout at grade intersection. So, ang different types of at grade intersections are simple, flared, channelized, and roundabout.